So I'll repeat myself for Andrew's sake here. So if the K is a big number, then this side becomes large, right? I mean, this becomes large, so that's a very big negative number on the right, which means a negative number here for the left, delta G. If K is very small, less than 1, this is not going to be thermodynamically favorable. It'll be positive. Or another way to say that is it'll be less, right? The smaller this is, the less negative that becomes, and eventually can become positive. So that's that. If, so we can, let me put that too. Or less thermodynamically favorable. So it's not just like, one big number, one little, there's varying ranges, right? So it can be less thermodynamically favorable. And then if K is equal to 1, so I'm going to write that in a second. If K is equal to 1, this is 0, that's 0, that's 0. That means it's at equilibrium. So I'll write that, and then we'll wrap that up. We're good here? Yes, yes. Joe, you with me? Okay. All right. And last part here, if K is, let's do this, if K is equal to 1, then negative RT natural log of 1 becomes 0. So delta G is equal to 0. It's at equilibrium. Alright, so I wanted to make sure I explained that a little bit better. Now I think what we'll do is just kind of intro electrochem a little bit, and we got about 7 minutes-ish. Questions about this delta G before I move on? Okay, so again, 27 through 30, chapter 17, due tomorrow. It's going to practice this using that. All right, so the last unit, electrochemistry. Here we go. All right. Electrochemistry. Let me fix my little Y there. It's an exciting unit. It's electric. Nice. Okay, just like that. All right. What is electrochemistry about? It's shocking. That's good, too, yeah. What's it all about? What do we do?
Ions.
Ions. There's ions involved. Yep, something else.
Electricity.
Yep, something else.
Chemistry.
What else?
Water.
How is electricity produced?
Flow.
Electrons doing what?
Flowing.
Moving, right. Electron transfer is a big deal here. Electron transfer. So let's just get through all the basics we should already know. And according to the AP Bible, you do not need to know, but I'm going to teach it. You already know it. But you do not need to know what reducing agent means or oxidizing agent means. Liar.
You're incorrect, because we did those.
All right.
Maybe 2 years ago I would have known.
Got it. So let's review here. Actually, you know what? Let me write one more thing here. Big deal here with this is converting chemical energy into electrical energy. And does anyone remember what kind of cell does that? That's turning light energy into electrical energy. That's different. We don't get into that, but that's cool. We talked a little bit about it when we did the quantum stuff. There's two cells. There's one called the electrolytic cell and one called the voltaic cell. But in AP Chem, we call the voltaic cell the galvanic cell. So which one? Which one takes chemical potential energy, chemical energy, and and turns it into electricity.
Probably the galvanic cell changes.
Yes, galvanic or voltaic. What do we call that in real life?
Battery.
Battery, right. So, converting chemical, that's the galvanic or voltaic cell. And we call those batteries. So we'll talk more about those. So again, they're taking the chemical potential, the chemical energy involved in a chemical reaction and converting it into electrical energy. And then the other way to look at this is the opposite. Converting electrical energy into chemical energy. And that's electrolytic cells. Electrolysis is how we really do that. Running electricity through water, for example. James is trying to perfect that. Running electricity through salt water or just molten salt. I mean, we're not going to do that, but it can be done. So that's when it's the opposite. We're taking electricity. These things have a power source, and the point is to make a chemical change. So use the electricity to make a chemical change. Stay with me. And then this is the opposite. You're going to have chemical changes result in electricity. So we'll talk about both of them, right? But it's all about that electron transfer. Who remembers the little acronyms I told you back in Regents? LEO-GR, right. What's LEO-GR mean?
Lose electrons, oxidize, gain electrons, reduce.
Right. Lose electrons, oxidize, gain electrons, reduce. That's really important to remember. Lose electrons, oxidize, gain electrons, reduce. This is going to be an increase in oxidation number. Your oxidation number is going to get bigger, right? If you start out as a +1, you're going to end up at a +3 because you're losing electrons. If you start out at 0, you become positive. Whereas gaining electrons, this is a decrease in oxidation numbers, right? Decrease in oxidation number. What else did I tell you? Any other acronyms you remember? In the cells, perhaps? Anox, red cat, right. Anox, red cat. So I'm just going to review all the big ticket terms here because it's going to help you, even this year. What's anox, red cat mean?
Anode oxidized.
The anode is oxidized, right. Anode is oxidized and reduction occurs at the cathode. So the cathode is reduced. So whatever's happening at the, reaction's happening at the anode, this is Leo. Whatever's happening at the cathode, that's the GR, right? Reduce.
Cat's GR. Is the oxygen Leo?
Yes, sure. And there's one more. Garfield.
Lasagna? Yeah.
He likes to eat a lot of lasagna, and it makes him
Fat.
fat cat.
Oh.
Fat cat.
Actually meant something with Garfields.
Fat cat. What does that mean? As a voltaic cell or battery is running, as it's being used, your cathode gains mass. Your anode gets skinny, and your cathode gets fat. So, because the anode loses mass because it's getting rid of all of its electrons, it's getting smaller and smaller. The cathode is gaining, eating up all those electrons. So I always say fat cat. So the cathode gains mass. So the only reason I'm doing this here is to refresh our memory of things we've already heard and learned about. So now we'll just apply them to what we need to know in AP Chem. Right? So tomorrow, I'll stop there. Tomorrow we'll do some reactions and get better at labeling charges and oxidation reduction half reactions and all that fun stuff. You want one worksheet tonight